break down what a force field is. A force field is any field where what? Where what? Force of attraction takes place. What do I mean by force of attraction? I'm talking about acceleration due to, I'm talking about force of what? Force of gravity. Force of gravity. On planet Earth, this is planet Earth. For as long as you are on planet Earth, whatever goes up must what? Come down. Why? We don't know, but the planet Earth, as you have seen it, it has different what? Region. There's what we call atmosphere. So this first atmospheric region that is closer to what? This planet Earth. Let's say this is planet Earth. Is what we call atmosphere. If you move higher, then you meet what we call the ionosphere. Ionosphere. If you move higher, you meet what we call the stratosphere. Like that, there are many. So immediately there is a particular region you get to where what? Gravity does not take place anymore. And that brings us to what we call your what? Your what we call space technology. Under space technology, at the region in the space, there is no gravity. That is, human being tends to float in air. American astronauts that have gone abroad, that have gone to the what? To the space. We have seen videos that shows that they tend to float in air, meaning that what? There is no what? Gravity in that region where they are. Not like our planet Earth. If you go to a 5-story building and you decide to what? Float in air, you will drop down and what? Enjoy yourself. Meaning that there is a force of gravity that is drawing on. So at that region now, at that junction, you'll be able to go into what we meant by work done in a force field. When there is a particular movement of an object, right from what? An upper altitude downward, there is a particular what? Work. A work is actually done in those regions. Let's look at this. A good example of force field is gravitational field. The force field is a gravitational field. So when I say force field, I'm also talking about gravitational field. Gravitational field. Now, what's a gravitational field? We said the gravitational field is any field where what? Force of gravity is being experienced. You can get to see the question anywhere, at any particular junction you go to, where you are being asked, what is a gravitational field? It's simply a field where what? Forces of gravity takes place. So it's a field where gravity, that is force, that draws the body downward each time that body is what? Suspended in air. So therefore, when the body is dragged with a force against the force of gravity, do you understand? When you have a ball tends to come down. Now the mass of this ball, let's say 20 kg. And there is now a force that tends to take this body up. That brings us to anyone that is carrying a body. You want to take a body upward. No matter how heavy this body is, there is always a force that wants to drag down that body. Now, for every energy you take to take this body against this force of gravity, and the force of gravity here, the normal what? Human force here. The human force is taking the body against that force of gravity. At that junction, a work is done. There is a work done. Why? Because whenever a force tends to counter this particular what? Gravity force, whenever a force tends to counter this particular gravity force, a work done is actually done. So at that region, it will then take us to the what? Mathematical formula. The mathematical formula. The mathematical formula for what? Work done in what? In force field. So that will take us to W, which equals what? mg times I, where your g is your acceleration due to gravity. So which is always 10 meters per second square or 9.8 meters per second square, depending on whichever one you are given. So that is for g, where your m is the mass of the body and your h is the height. What height? The height at which one the body is what? Moving. The body is at 0, is moving to this particular height. From here to here becomes the height. So that is the what? Formula for your work done. Sorry, mgh for your work done under what? Under your force field. So at this junction, we'll proceed to energy. Before we talk about energy, you need to understand what energy is. energy itself is different from work done. Although they are all being measured, they are both being measured in what? In joules. They are both being measured in joules. But you must know the actual definition of energy. Energy is defined as the capacity to do work. You have the capacity at which you apply to do a particular work is called what? Energy. You are sitting down at home, you are being told to carry a particular ball or to carry a particular keg of water. When you carry the water, do you understand? Against force of gravity, you perform work. But that energy you used to, that capacity, that your capacity to carry that keg or that particular body off the surface at which is lying down, that particular capacity is what we call your energy. So energy is definitely your capacity to perform work. And I said it earlier that the SI unit is still joule. Now, at this junction, we'll look at the various types of energy. The various types of energy. Energy is actually classified into more than 4 or 5 types. But at this junction, we restrict ourselves to just two, based on the level of what? Based on the class at which we are considering. Now, types of energy. We have what we call your kinetic. We have what we call kinetic energy. We have what we call your potential energy. As we move on, as we proceed in this study guide, we will be able to realize, I will be able to look at all these types of energy by breaking them down single-handedly. That is, kinetic energy itself is a little bit deeper. It has a lot of what? Subtopics under it. So, first of all, we need to actually look at all the what? Classes of what? Energy. We have what we call chemical, we have what we call heat, we have what we call electrical energy, we have what we call sound energy, we have what we call light energy. They are all types of what? Energy. Let's recall kinetic, potential, chemical, heat, not just heat energy, electrical energy, and light energy. So we are going to be basing our discussion on just two, a kinetic and a potential energy for now. But as we proceed, we'll be able to break down all other types of what? Energy and how they relate to science. Now, let's start. Kinetic energy. Let's start with kinetic energy. What is kinetic energy? Kinetic energy is it's very simple. If you look at the word kinetic, kinetic is broken down from the word active movement or excited movement. When I say excited, in science, when you say excited state, what is the excited state? Excited state is a state at which a body tends to what? Undergo random motion. When the body is vibrating, when the body is what? Moving in what? In an unknown direction. Excited state in sciences is a state by which a body tends to what? Exhibit what? Random motion. Now, what am I saying in essence? What am I saying in essence is that kinetic energy deals with an energy that has been what? Exhibited due to what? Movement. Due to what? Movement. Energy exhibited due to movement. Meaning that if I push a body, or if I decide to push this body now, for as long as this body moves from point A to point B, this point A and this point B, the type of energy exhibited by this body is what can be what? Kinetic. But when a particular body tends to what? Exhibit energy at states. Do you understand? Or at a stampede. When I say stampede, at a point, it's not moving. It didn't move, and energy is being exhibited by that body. That type of energy is now what we call what? Your potential. So you can code it by saying potential energy is an energy that is being exhibited, or is an energy that is being practicalized at what? By a stable body. a body that doesn't move, a body that stands in a what? In a particular position. While kinetic energy is a type of energy that is being exhibited due to what? Motion. So you can code it that way so that you won't mix it up. What's the difference between potential and what? Kinetic energy. Potential is what? Energy that is due to what? State. While kinetic is an energy that is due to motion. So those are the two major type of energy that will be what? Making use of to actually what? Proceed in this what? Topic called energy. Now, let's go to another one. We have your power. We have the power. Power. What is power? Remember, we have dealt with work. We have dealt with energy. Now, we are going to power. You must be able to what? Differentiate between these three: work, energy, and power. Energy, the reason why energy could not be dealt with in terms of those types of energy given is just because if we proceed, it's going to be beyond the scope of what? SS1. So when we get to our SS2, we'll be able to what? Give distinct description of what? Energy. Now, let's go to power without wasting much of our time. Power is defined as a rate of what? Doing work. Rate. Power defined as the rate of doing work. So they are all what? They are all coming back to what? Work. What do I mean? Work is what? You say work is the movement of what? A particular body, the direction of that force. But energy is the capacity to do this same work. While power is the rate. When I say rate in science is what? Time. The time you spend in doing a particular work is what we call what? Power. You apply a particular power to do a particular work. Now, I mean, you apply a particular